Hi guys, welcome to session 32 of Java Full Stack Made Easy. In the previous session, we discussed about the concept of Java Lambda expressions, right? This session was actually recorded before and it had no voice. So because of which, again, I'm re-recording this particular session. And also, if you look at the repository, since it was already recorded, so you can see that there are 7 demos which I've already added into the repository. So in this session, what I am going to do is I'll be showing you the same demos that I have already covered up in the session which was not recorded. We will just go through the things one after another and then understand the same thing once again. So sorry for the inconvenience caused. So let me clean up everything that is written here as for now. So now let's first talk about something called as the for each method that was introduced into Java 8. So we will see for each method with lambda expression, and then we can go ahead with the uh, concept of method referencing. Fine. So now the first thing is like in the previous session, I created the instances of player and everything, right? So I'll go back to my previous session, that was session 31, and the last example of session 31 where I created a list and I iterated it by using a for loop, right? So demo 9. So this was lambda, anonymous classes and everything, right? Lambda with comparator is something, yeah. So this is what I did in my previous session. So this is what I want. So let's copy this. Let's put it here. Fine. So all this import should happen. List, array list, collections. So let's import all of that. So this was my last example as per the series that is going on. So in this example, I used a for loop, right? Similarly, what I want to use now is I want to use a for each method that is provided with the collections from Java 8 and also see the difference between these two. So how can I make use of the for each? So with every collection that we have, so in this case, I have the collection as players. So I can simply say players list dot for each. So you can see that there is this particular method for each available for us, so which can be used to iterate over the elements of a collection. So now it is again simple. I can make use of a lambda expression here so that it will be easy for us to iterate over the collection. So let's go ahead and see how can we do that. We can simply say x a lambda expression and then start and end of the lambda system.out.println. X will store every single object of that particular player available. So we are done with it. Let's save it and run this, and you see this is how we can iterate over the collection and then get the results. Fine. Similarly, what we can also do is, this is just about the printing of stuff. I can also manipulate if I want, because end of the day this X is nothing but a player object. So I can simply say players dot for each. X is something which I generally use with my examples, but in case in reality it is what? It is an instance of player. So what I can simply do is I can go for a player dot, let's print the get name into upper cases. Okay. So that's what we can do. Let's save it and run this piece of code. So you can see that only the name of the player is retrieved and that is printed in the upper case. So this is how we can make use of a for each that was introduced into Java 1.8. Okay. So now let's move ahead and talk about the concept called as method referencing, which is nothing but what? A method referencing is kind of a shorthand for a lambda expressions. So it is a shorthand notion of a lambda expression to call a method directly. So we will understand what exactly method references are, in which scenario we have to make use of the method referencing and everything. Fine. So first thing is that in this examples and everything, this is already added into the repository in the repository that is created, which is day 32. So I'll be referring with the same demonstration. I'll go with the same demonstrations. Some few things here and there can happen, but most of the things will be the same itself. I am taking same examples. So this was up to here. I have already created the stuff, right? So only this new thing I added in here, and the player dot uppercase. Fine. So similarly for the other examples also I'll be referring the same thing itself. So you can simply go ahead with the same demonstrations that are available in the repository itself. Fine. So let me now talk about something called as the method referencing that was again introduced into Java 1.8. Now what is the advantage of method referencing? Why to use method referencing over a lambda expression? Let us understand that. Okay. So either a lambda can be used or a method referencing can be used. It will be your choice depending upon the scenario, depending upon the situation. You pick up either a lambda expression or you pick up the method referencing. Let me just clean up everything that is written here and let us understand what exactly method referencing refers to and what it is all about. So let's create an interface. Let's call it as a test interface or my interface. Okay. So I'm creating a test interface, and within this test interface, I'm creating one simple function. Let's call this as ABC function. And what I will do now is, since I already have this Java 8 demos, I'll be creating one method over here, which I'll just create it as public static void. Let's call this as something like my method. Okay, I hope the same name I have given in the previous demo also. So my method I'm trying to create, and in this method I'm just gonna say system.out.println, and I'll say this is my method demo. Okay, so in this case, see what happens is that when I was using a lambda expression, I have to simply just do what? I call this ABC and give the body of this a particular ABC method, right? So if it was a lambda, see, first of all, this is for using lambda, this has to be a functional interface. Definitely it is a functional interface now as well because it contains only one single abstract method. So I can just put a functional interface annotation on top of this just to verify that it is a functional interface or not. So it is a functional interface, and because it is a functional interface, what we can do is we can simply make use of a lambda expression for the same. So we can go for test interface that I have created, right? So test interface is created. So let's call it as test interface t is equal to, if it was a lambda expression, then we would have done something like this, right? And then system.out.println, this is lambda. So now that we are not using a lambda expression, we want to use a method reference. Let's see how can we provide a method reference. So again, you create a test interface, the instance of that, let's call it as t1 is equal to, and instead of using a lambda expression, now what I'm gonna do is I'm just gonna refer to the method. Also, yeah, first let's see the syntax. So this is how we refer to a method, my method, done. We are done with the method referencing. Now if we call t1.abc, so in that case we will be getting the result of this particular method whenever we call the abc. This is because we are referring this my method with the abc method. So whatever is written in my method, it is as if like we have overridden this, we have implemented the interface and overriding this particular method. It is same as that. So let's run it and see the result. So this is my method demo is being executed, and yeah, also the lambda expression I have written. So t dot abc, let's call that, and the lambda is also being executed. So this is how we can make use of the concept of either a lambda expression or the method reference. Now what is the difference between having a lambda expression or a method reference? So it says that it is a shorthand notion of referring a method directly, right? So what would be the advantage, and in which case I'm going to make use of the lambda expression, and in which case I'm going to make use of the method reference. So if you look at the concept of this lambda expression, if the method grows, that means if there is a lot of code that has to be written in the body of a method, then writing it this way looks more complicated than implementing it this way, right? So this is clearer way of doing it, right? So if it is just an expression, like if you remember in the previous example, I created a converter and then I just passed in the value, it returned me the value, right? If it is that case, then it is always better to make use of lambda expression. If the method contains a lot of coding into it, a lot of code into it and a lot of logic into it, it is better if you go for a method reference rather than going for a lambda expression. So we will be having both the options. So either if you're comfortable with lambda expression, you go for the lambda expression. If you're comfortable with the method referencing, you can go for the method referencing. But what I suggest is, if a method contains a lot of logic into it, then you better go for a method reference. And if it is a simple logic that is included into a method, not much code into a method, then you can easily go for a lambda expression rather than going for a method reference. The advantage of lambda is that it does not create a new method for you, whereas in method referencing the advantage is that it is a clearer reference to a method. You write all the logic inside a method and then refer that method here. Limitation would be that you have to create a new method for that. Fine. So obviously again methods can be static or it can be non-static as well. Fine. So and there are certain set of rules that we have to follow while performing method referencing. Again, this demo is also provided into day 32. So if you want this demo reference, I can simply put it into the uh, file and I'll call this as new demo 2 or something like that. New demo 2 method reference static. Okay. All right. So that would be better. And I'll also give you, yeah, previous example is same as the first one, so I'll not give you that. Now, in this case, one more important point that we have to remember while creating method reference is that, see, the return type of this particular method as for now is void. That means this method does not return anything, right? And what I write with the method reference is that this method returns something like maybe int, and I'm going to say return, let's say some value, maybe it returns 80 and I save it. Now you can notice that I'll remove lambda expression for now because lambda is of not a concern for us as for now. Our focus is completely on the method reference. So I have provided a method reference t1.abc, everything is written. So let's run this and check whether this particular method can be referred or not. So when I run this, you can notice that the method can be referred even if the return type is different. Fine. So this is again once again a very important topic to focus on. Return type is different, the method is valid here, right? The above one is void, this one is int. So what about this value, this 80? Can ABC return that 80? So logically saying no, it should not return 80 because while I was creating this particular method, it was returning void because I did not know while creating this interface, I did not know somebody is going to provide me a method reference, right? So I was not expecting this return type 80. So I'm saying that it is void, it's not returning anything. So it should not return you any value. Let us test that and see whether technically it is correct or not. So int x is equal to t1 dot ABC. The moment I write this, I'm going to get an error because obviously ABC does not return anything. It says type mismatch cannot convert from void to int. So this definitely should give you an error. So logically it is correct. Although we can provide that type of syntax, ABC is void. Fine. So let me put this into the repository. First thing is that it is valid. If the above method is void and the below method is int, it is completely valid. Let's call it as new demo 3 return type. So in this case, with the different return types, it worked very fine. Now what I will do is I'll just change the return types. Like the above method, I'll say int, the below method, I'll say void. Okay, so let's see what happens in that case. So if at all I say this above method as int, let's say while creating this method, I know that this method should return something. If it is a method like sum, let's say for example, if it is a method like sum, and I'm expecting this to take int x and int y. So my intention about this method is to return the sum of these two numbers that are provided here. So if somebody comes up and then says that this is my method and again I will take the value int x and int y, it is valid. Now yeah, here the result is sum is there. So I am returning, let's say 80 plus 20, so that should return us 100. All that is fine. And now I provide in a sum. So looks good. Then my method, yes, fine. So let's save it and let's see what is the error. Now the method sum int not applicable for the arguments 0. My method now comes up with yeah, two arguments are there, so we have to pass in two arguments. That is 80 plus 20. Let's here instead of adding 80 20, let's add x and y so that it adds up all the values provided by the user itself. Fine. So let's add 30 plus 70 and see the result. Obviously this sum now returns something. Let's say int x is equal to, and x will store that particular value, system.out.println. x. Let's save it, and we are expecting it to return 100, so it is returning us 100, completely valid, so looks good. So one more important point is that, see, the method is taking two arguments and the referencing method must take two arguments only. If I provide only one argument, at that time it is wrong, because the above method is taking two arguments. So below method signature should match. Okay, do remember that point in your mind, that the method signature has to match. If the above method takes 10 argument, below method also has to take 10 argument. Let us change the type and test whether it is possible or not. Even if the type is changed, then it is still not possible. Okay, the types also should be the same itself. Do remember these points. So I'll put this again into the repository. Let's call this as demo, a new demo for method reference signature. So the signature return type, signature, that is the argument list, should be same. Return type also should be same. So what I'm doing in this case is that I was expecting that the method is going to return me an integer value. Whereas in the below case, I come down and say that this method is returning void. It does not return any value. So I just remove that. Now the moment I do this, you will notice that the error will be given to me. See, you can see that the method type of my method int from the type Java demo is void. This is incompatible with the descriptor's return type. That means the above method, which is a descriptor, the sum method, returns something, and you are saying that it does not return anything. So at that time, you're actually breaking up the logic where the data, where there is a chance of loss of data. The return value might be lost in this particular function, right? The return value will be lost because this method cannot return anything. Whereas while creating this method, I said that this method must return a integer type of data. Fine. So this is definitely going to give you an error. Even if I take, instead of void, you might say, okay, let's take long, because long can easily be converted into an int. In that case also, it is completely invalid. Let's try and take something like integer, where the concept of auto boxing works, right? So let's return x plus y. Fine. So concept of auto boxing comes into picture, and then it is completely valid in this case. Fine. Whereas if I provide it as void or maybe long, let's try and give a long wrapper and test whether this works fine or not. So two errors. First of all, this result will be returned as an integer, so we have to convert it to a long value, and here also the return type will be mismatched. Fine. So it can either be the same or a wrapper. If it is a primitive, then it can be a wrapper. Fine. So this is something that you have to keep in mind while creating a method referencing. Fine. So I'll put this into the repository, and that should actually tell you this actually definitely this function itself contains an error, though the error itself is teaching you that the return type must be the same. Okay. So first of all, if it does not return anything, the return statement should not be written, and here it is an error, that is a return type incompatible. Return type incompatible. Okay, let me share this with you. That's demo 5. Return type of method reference. So I hope the rule is clear to you. It should either be the same, or if the above method returns void, then the below method can return anything, either void or anything. But if the above method has a return type, then that same return type has to be taken to the referencing method as well. Fine. So now in the previous examples, what I have done is I have actually taken a uh, static method. So methods can either be static or method can be non-static as well. So let's see, what if the method is non-static? At that time, how can we provide a reference? So let's test that. Let's go ahead here and just simply let's have this, and let's make it valid by making it int and returning x plus y, signature and everything. Now it is completely valid. Now what I'm going to do is I will simply just remove the static from here. It's a non-static method which I have created. The moment I add that here, you can notice that again it started giving me an error. That is because static functions can easily be called without an object reference. Whereas if it is a non-static method, it requires an object for its existence, right? So we need an object reference now. So let's see how can we provide the object reference for the same. So the syntax changes when it is a non-static method. So we have to provide an object reference, and then from that object we have to take the method. So this is how we do it. Fine. And obviously the next line would remain the same. So let's save it and run this. So this is how we can refer to a non-static method. This is one way where I'm using a one-liner, and the traditional way, if you require this object that is being created here in future also for calling other methods and other functionalities and all. So at that time what you have to do is you have to simply create it the other way around, that is Java demos, j is equal to new Java demos, and then while performing a method reference at that time what we can do is we can use that j to provide the reference. Let's call this as t2 and t2, and let's call this as x1. So I usually in the demonstrations I use this method names like t2, x1, xy, z and all that. In real time you should never be using such names. Always give meaningful names to your functions that you are creating. Fine. So in this case, instead of directly writing new Java demos, I'll just be using a J there, and it all works the same way. Now let's, instead of 30, let's just try and add up 40. So the second result should be 110 for me. So I'm printing X here. That's why it is not returning me the result. X1 should be printed, and there we go. 110 is printed. This is my method. So this way we can refer to a non-static method. So if it is a static method, you directly write a method. If it is a non-static method, at that time the object has to be created, and then using the object or the one-liner, the constructor can be referred this way. Fine. So let me copy this as well and put this into the repository as my demo 5. New demo 5. This is non-static method reference. All right. So we referred a static method, we referred a non-static method. We can also refer a constructor. That means if suppose this method is not a normal method, if it is a constructor, let's put a constructor. Constructor doesn't take any return type, so we'll not have a return type here. And obviously in that case, the method should be void in that case, right? So let's write a void stuff here, and system.out.println itself I will write x plus y. So let's save it, because we know that constructors does not return anything, right? The return type of a constructor is not valid. If we write a return type to a constructor, it will not become a constructor. It is going to act like a normal method. So that's again one more important point that you can remember. Fine. So now what if it is a constructor? So what I'm gonna do is, although now that I have written a constructor stuff and everything, so let me just go ahead and refer it with the concept of constructor. So what I've done here now is, let me just clean up everything that I have written here. So here I have the reference t2 j instead of this j and all that. Since it is a constructor, so what I can simply do is, it is a constructor of which class I should know, that is Java demos. So I have to write that Java demos it, and then the method reference, just you type in new there. So the moment you write it as new, so at that time what it is going to do is it is going to understand that the user is trying to actually refer to a constructor. So save it, and there we go. Now this is not just my method, this is a constructor. So because it is a constructor, we are using a new keyword, and by using a new keyword, it understands that you want to refer your class constructor to the above method. 4070, that's actually a concatenation of 4070 4070. So let's put it inside the bracket so that it can add it, not concatenate it. So now it has added 110 is the result. So let's save it, copy this, and this is how you can refer to a constructor. So this is my demo 6 referring a constructor. So let's call it as demo 6 method reference constructor reference. All right. So even like the built-in methods can also be referred, not just the methods that we create, even the built-in methods which are available to us can also be referred. Like for example, a println method can be referred. So let's go ahead. There was error committing your changes. A file with the same name already exists. Sorry. So let me cancel this, and this is not demo 6. Let's call it as new demo 6. All right. So that's saved. All right, so let's go back, and I was talking about referring to the built-in methods, like println method, which is already created built-in method println here, right, which is coming from what system.out. So let me try and test how can we refer to this particular method. And for that, once again, I'll try and take a real-time example itself. So let's remove this interface stuff and everything, and also remove the constructor. So what I will do is I'll go to the first example that we have written. So demo 1 for each. So this is the first example that we discussed. Let's take that once again, and yeah, up to here, let me copy and put it here. Again, collections, list and array list. So let's import that. So mainly what it only has is it has the three players are created and they are all added to a list. Fine. And using a lambda expression, I iterated over this. I want to iterate over the same thing by using a method reference. Fine. That's the only agenda that I have. Fine. So let me just simply say uh, it is players in our case, right? Players dot for each. Now I have to use a system dot out. So let's just use a system dot out and refer a println method. So this is system dot out colon colon println. Fine, that's it. That's it. So we should be able to get the result. So also what I'll do is system.out.println, below is method reference result, so that we can understand the result of method reference. So in the it is also possible with the lambda, also possible with the method reference. The above two are using lambda expression, the below one is using a method reference. Same as what we did with the lambda expression. Lambda expression looks like this, whereas method reference looks like this. Whichever feels easy to you, you can go with that particular approach. Because of what? Method reference is nothing but a shorthand notion of lambda expression to call a method directly. So hope the concept about this is clear. I'll also put this into the repository. Let's call it as method reference. This must be my demo 7 or something. New demo 7 method reference println method. Fine. So hopefully this concept is clear, and also the voice is recorded into this session at least. So sorry for the inconvenience. I had already recorded this particular session, and because of the technical issue, I have to re-record this. So because I don't want to disconnect the sessions, so that's why I have re-recorded it. Recording the session on YouTube definitely takes time. It's not like a live classes. Live classes are far more easier than the recorded session on YouTube, because in live classes there will be people who would be reminding me whether the mic is working or not, and also during the live sessions there is a live conversation between people and me, and in the YouTube sessions there is no live conversation, so you have to just imagine it on your own. And obviously recording the half an hour session definitely takes a lot of effort behind it, so it takes a lot of time as well. Time and effort has to be put to record sessions. So I hope you also appreciate that effort which I am making to put things together and make it easy for people like you to get a job into the industry, because the market is very tight and there's a lot of competition. Until and unless you have skills, you are not in the market, right? So do share this videos with your friends, comment on it. If you have any doubt, share and subscribe, and let's grow together. See you in the next video. Thank you.